I hope you're all well and that you are on task with all of your topics that we are busy with grade 10 maths. Today we're going to do a video on all the types of exponents that you can get. And exponents, I know they do get a little bit hard. After this, we're going to look at algebraic equations and inequalities. So that's what's to come after this topic. And so I just set out what do you call it, like a summary of all the types of exponents that you can get. All right, so if you break it into two, there's simplifying expressions with exponents and there's simplifying equations with exponents. Underneath simplifying expressions, you get exponents with prime bases and simplification of expressions involving factorization. Mainly your three big types, HCF, difference of two perfect squares, and a trinomial. Then the simplification of equations is solving exponential equations and solving equations with fractional exponents. So that means there's a fraction on top as the exponent. All right, so I'm going to keep this going and we're going to just move all throughout doing the different sums. So first of all, I'm going to do the left-hand side, which is simplifying expressions. All right, so exponents with prime bases. So what I've taught my students is I said every time you see a number with an exponent at the top, we have to make it an exponent of an x of a variable. We have to change it into a product of its primes. So if you can see over here, there's an 18 that I need to change, an 8, a 9, and a 4. So all of those are not prime bases. So I'm going to change them into a product of their primes. So 18, if you put it in your calculator, remember you press shift, you put in 18 equals shift and then that dot comma button, which is the factor button. Okay, all right, so if I put in 18, it changes, or it gives me 2 times 3 squared, and that is all raised to the power x still, so you can't just drop that x. Then times 8 is 2 to the power 3, that 3 pushes up and it needs to multiply with the x minus 1, the x and the negative 1. The 9 becomes 3 squared, that 2 pushes up and it multiplies with the x as well as the positive 1. Times 2 to the power 2, that 2 pushes up and it needs to multiply with the 2x minus 1. So it will really be in your benefit if you rather write more steps than lesser steps, okay? Because you might just make a mistake somewhere. So step 1 is I replaced the numbers that weren't prime numbers inside brackets what it told me on the calculator, and then the power, the exponent still stays there. And now we can go and take those exponents away. So everything inside the bracket is to the power x, so it's going to be 2 to the power x times 3 to the power 2x times 2 to the power 3x minus, and then very important, the 3 also has to multiply with the negative 1, which gives you negative 3. All over 3 to the power 2x plus 2 times 2 to the power 4x minus 2. All right, and now I'm going to keep my base and add the exponent. So all the ones that has a 2 as a base, let's make it another color. I'm going to keep that base and add those exponents, and if it's underneath, I subtract those exponents. Okay, so let's do it in green. So it's 2 to the power x plus 3x plus minus 3 stays a minus 3, and I'm going to subtract, very important to put it in brackets, I'm going to subtract 4x minus 2. Why? Because that negative has to distribute to both terms. And the other side is times 3 to the power 2x minus 2x plus 2. Okay, sorry, you can't see it so nicely there. And then I'm going to simplify. So it's going to be 2 to the power x plus 3x is 4x minus 3. Let me just distribute that negative first before I finish it off. So it's x plus 3x is 4x. Oopsie, sorry. And minus 3 minus 4x plus 2 times 3 to the power 2x minus 2x falls away, and 3 to the power a negative times a positive is a negative 2. All right, and now we can simplify this. 4x minus 4x falls away, minus 3 plus 2 is negative 1. So my answer is 2 to the power negative 1 times 3 to the power negative 2. And that would give you 1 over 3 squared is 9. 9 times 2 gives you 1 over 18. And there you have it. Sorry, it's a bit squished in here. Let me make a little thing like that. Okay, to cordon it off. All right. So again, just remember your calculator can do negative exponents. So if needs be, you can just put it in your calculator as it is there. 2 to the power negative 1 times 3 to the power negative 2. All right. So which ones aren't prime numbers? The 6, the 9, the 54. And here, although it's a quarter, there's a 4 underneath. So the first step is I'm going to change it into a product of its primes. Now 6 is 2 times 3. And it's all raised to the power 6x times 3 to the power 2. That 2 pushes up and multiplies with the 3x. All over 54 equals shift fact. Gives you 2 times 3 to the power 3. And that's all raised to the power 4x. And now, what is a quarter? So remember, a quarter is 1 over 2 to the power 2. So when I bring it up and I want to make it a base number, then it's going to be 2 to the power of negative 2. So that quarter is going to change into 2 to the power of negative 2. Oopsie. Okay. So 2 to the power negative 2, all raised to the power 2 minus x. Okay, then we're going to go through with the exponents. Everything inside the bracket is 2 to the power 6x there. So it's 2 to the power 6x times 3 to the power 6x times 3 to the power 2 times 3 is 6x. All over 2 to the power 4x times 3. 3 to the power 3 times 4, a power raised to a further power. Sorry, you multiply. So 3 times 4 is 12x. Times 2 to the power a negative 2 times a positive 2 gives you a negative 4, and a negative 2 times a negative x gives you a positive 2x. All right, so let's just see negative 4 plus 2x. All right, now all the ones with the same bases, there's a 2 to the power 6x, and here's a 2 to the power 4x, and here's a 2 to the power negative 4 plus 2x. Okay, so let's do those ones first. 2 to the power 6x, and now because they're at the bottom, we're going to minus 4x minus, remember if there's more than one term, it's best to put it inside brackets. Okay, and then that's going to be times by, let's do that in the other color, 3 to the power 6x plus 6x is 12x, minus, at the bottom there's a 12x. All right, then let's simplify further. So it's going to be 2 to the power 6x minus 4x is 2x, plus 4, because a negative times a negative is a positive, and a negative times a positive is a negative 2x, times 3 to the power, what is 12x minus 12x? It's 0, and anything to the power 0 is 1. So 2 to the power 2x minus 2x falls away, so it's 2 to the power 4 times 1, which will give you, and I'm sure it's 64, it's 16, sorry. 2 to the power 4 is 16. And there you have it. Okay, so those are the prime bases. I just used 2, and it's best, and I know it takes long, but it's just step for step. It's just meticulous work to make sure that you do not make a mistake somewhere. All right, okay. All right, and next up we're going to look at simplification of expressions involving factorization. Okay, so factorization all over the show, all throughout the year, forever and a day, amen. Okay, so with these ones, we want to take out a highest common factor. So can you see that there's a 3 to the power x at the top? So the top we need to factorize. Why? Because there's a plus in between. All right, so we don't have one term. We need to first make it one term so that we can cancel out. So I'm going to take out 3 to the power x at the top. Then what is left is 3 to the power of 1 plus 2 times 3 to the power of 2. And if that 2 was a negative 2, then you say 3 to the power negative 2. All over 7 times 3 to the power x. Okay, now 3 to the power, now I can go and cancel out because I've got one term at the top and one term at the bottom. So that what is left, you can just put it into your calculator, or otherwise 3 squared is 9. 9 times 2 is 18. 18 plus 3 is 21 over 7, which gives you 3. All right, I have dealt with these in my previous examples of my previous video as well on exponents. Okay, so prime base, everything that has a little xy on it at the top of an exponent, you need to make a prime base. These numbers, you don't have to because they don't have a little exponent at the top of them. Okay, so only the one who has a little xy at the top. So 25, the prime numbers is 5 to the power of 2x minus 36 over 5 to the power x plus 6. All right, so now I'm going to change. I'm going to do the old switcheroo and then say that it's 5 to the power x squared. So that I just rewrote, and I've explained this in my previous video very carefully. So it's 5 to the power 2 all raised to the power x. Do you see that if I work backwards, it will give me 5 to the power 2x again? Because a power raised to a further power, you multiply. So all I do is the old switcheroo, and I just swap those two around because x times 2 still gives me 2x. Okay, minus 36 over 5 to the power x plus 6. Now, what I do is, it's the K method. So we just, because it's sodium occard and we want to just make it a little bit more easier for ourselves, we're going to say let 5 to the power x be equal to K. All right, so that is my, I'm just going to replace it with K. We just use K because it doesn't look like another number, and I don't know, it came out to be the K method. Okay, so I'm going to replace it here. So it's K squared minus 36 over K plus 6. And now that looks very easy to factorize. Can you see it's the difference of two perfect squares? So we're going to have K plus 6 over K minus 6 all over K plus 6. And then you can go and cancel that out, and your answer is K minus 6. But if you leave it like that, you're going to miss out on a few marks, because you need to go and replace, oh sorry, there goes our bell. You need to replace the K with 5 to the power x. So 5 to the power x minus 6. And that is your answer. All right, then the last one exponential, solving exponential expressions. Again, we need to take all the numbers that aren't prime numbers, and we need to make it a prime base. Why do I not need to make this 4? Because at the top there's to the power 1 and there's no x at the top there, so we don't have to make it a prime base. Okay, so 4 to the power x is going to become 2 to the power 2 multiplied with the x's, 2x. Do the old switcheroo, so it's 2 to the power x squared minus 4 times 2 to the power x plus 3 all over 2 to the power x minus 1. Now, it looks horrible. I'm going to change and make and say let 2 to the power x be equal to k. So can you see I've got there 2 to the power x, I've got here 2 to the power x, and I've got here a 2 to the power x. So let's just, for ease of seeing what the heck is going on, make it 2 to the power x is k. So then we've got k squared minus 4k plus 3 over k minus 1. And now we can easily see that this is something squared, something x, just a number. Okay, so it's in that format of a trinomial. So you always set it up, 2 brackets, the signs are the same, and they are both negatives. And what times what gives you 3? 3 times 1, if you minus 3 minus 1 gives you that negative 4. Oopsie, sorry. And that's all over k minus 1. Whoop-de-doo, I can cancel out there and say that my answer is k minus 3. Okay, don't get glad, you're not done yet. You first need to go and replace that k was 2 to the power x. So 2 to the power x minus 3. And that is your final answer. Alright, let's move on to simplifying equations. So first up, solving exponential equations. Alright, so first step. Can you see over here, step 1 is, let's write out the steps. Step 1 is divide out with a number to simplify your equation. Okay, so divide with a number to simplify your equation. So then, can you see that both of these I can divide with 4? Alright, so then this 4 and that 4 will cancel out, and I'm left with 25 to the power x plus 3 is equal to 1. Okay, 25, I'm going to make a product of its primes, so it's going to be 5 squared. That 2 pushes up, and it multiplies with the x and the 3. Okay, so I'm just going to do that without writing that step. So it's going to be 5 to the power 2x plus 2 times 3 is 6. Now, do you know that you can make 1 into any prime base? Any prime base. Okay, so 1 can become, I could have actually there said 25 to the power 0. But I didn't now. Okay, so let's stick to our carrying on with making a product of its primes, the 25, and 5 to the power 0 will most give you 1. Okay, so just remember that if you get 1 on the other side, that you can make it a product of its primes always that is similar or the same as the one on the other side. Not similar, the same. Now, you can say, I drop it like it's hot, and then you equal the exponents to each other. So 2x is equal to negative 6, so x is equal to negative 3. So can you see over here, I just want to show you that over here you could have also said 25 to the power 0. Drop it like it's hot, and then say x plus 3 is equal to 0, thus x is negative 3. Okay, cool name. Alright, over here, we hate decimals, we hate fractions. Let's just change them immediately. So step 1, there's no number that I can divide out that makes it easier. So 0.5 I'm going to turn into a half, and that is all raised to the power x minus 1. And a quarter I know is 1 over 2 to the power 2, all raised to the power x. Okay, now I want to get rid of my fraction. How do I do that again? By taking the 2 upstairs and changing it merely into a negative. And that gets multiplied with x minus 1. And the same over here. So it's 2 to the power negative 2, all raised to x. Okay, so now you can already drop it like it's hot, but let's just carry on before we do so. 2 to the power negative 1 times x is a negative x, plus 1 times 1 is 1. is equal to 2 to the power negative 2x. Then we're going to drop it like it's hot. When can I drop it like it's hot? Only when there's one term on each side and they've got the same prime base. So negative x plus 1 is equal to negative 2x. Take it over to that side. Negative x plus 2x gives you x is equal to negative 1. Just want to make sure negative x plus 2x gives you 1 and negative 1. Cool. All right, next one. This is a bit of a funny one, a bit of a harder one, a bit of a stand out and don't know what to do one. Okay, so let's try and divide out with 8 on both sides to get rid of this 8 and to bring it in there. Now, we're also going to divide out with 27. Okay, so if you divide here with 27, it will fall away. And the 27 will go and stand over there. So at the moment, we've got 3 to the power x over 27 is equal to 2 to the power x over 8. Then we want to, I just want to quickly see something. Then you're going to times with 27 on each side. So this is really like a bit of a hard one. Times of 27 on each side. So that will give you 27 times 2 to the power x over 8. And then you're going to divide away with 2 to the power x. Okay, so it's a bit of a long dividing out so that we've got the two prime base with the exponents on the one side and the numbers on the other side. So, can you see that 3 to the power what gives you 27? X must be 3. Let's just check it at the bottom. 2 to the power 3 does give you that 8 over there. You could have also turned it into a product of its primes. You could have said 3 to the power of 3, 2 to the power 3. Then you drop it like it's hot. So even if it's on fraction form, you can do that. And you equal, you equal the exponents to each other. Thus, x is 3. Okay, but like I said, a bit of a hard one. Not so lekker. Okay, but I thought maybe let's just do that one. All right, over here, do you see we're going to have to use factorization for that part? So anything that is not prime numbers with a little xy at the top, we need to change into a product of its prime. So it's going to be 3 to the power 2x plus 3 to the power 2x plus 1 is equal to 36. So can you see that I can take out a 3 to the power 2x as a HCF? So 3 to the power 2x. Now what is left? Can you see, that if I had 4, I'm just going to give you an example, and 4 plus 8x. Oh, no, not that, sorry. 4 plus 8x. If I take out a 4, what's going to be left? Can you see it's 1 plus 2x? So if you take out exactly the same, there's 1 left. So again, look at this sum over here. So if I take out exactly what was there, what's going to be left? A 1 plus 3 to the power 2x is gone. One thing that is left is 3 to the power of 1 is equal to 36. And now we're going to say 3 to the power 2x is equal to, that is times by 4. Let's just show that step is equal to 36. Now can we divide away with that 4 on each side? And then you get 3 to the power 2x is equal to 9. I want to make sure 36 divided by 4 is 9, which will become 3 to the power of 2. And now you drop it like it's hot. So 2x is 2. Thus, divide by 2 on each side, x is 1. So let's just see, in the beginning, let's just go put it in. So if I said x is 1 and 1, 2 times 1 is 2 plus 1 is, 2 times 1 is 2 plus 1 is 3. 3 to the power 3 is 27. 27 plus 9 to the power 1 is 9, which does give me that 36. So even here, you can always go and test your answers. All right, moving on to the next one. Just want to bring another color in. Okay, so anything that is not, prime basis, like this 25, and it's got to the power x, we need to change into a product of its primes. So we know that it's going to be 5 to the power 2x minus 6 times 5 to the power x plus 5 is equal to 0. So most of the time when you get a 5 to the power 2x, remember the old switcheroo. So it's going to be 5 to the power x squared minus 6 times 5 to the power x plus 5 is equal to 0. Okay, so now because I've got 5 to the power x twice, you are welcome to say, let 5 to the power x be k, just to see what the heck is going on here. So then we've got k squared minus 6k plus 5. So you go and substitute everywhere where there's a 5 to the power x with a k. And now we can see this is a lovely, lovely trinomial. So it's going to be k, the signs are the same, they're both negative, and 5 times 1. All right, check it. Yes. So then we can say k is either 5 or k is 1. Remember, if you've got two brackets equal to 0, you can equal them to, both brackets are then separately equal to 0. Sorry. So now please remember that I need to go and change the k as a 5 to the power x again, and over here 5 to the power x is 1. All right, so not done yet. I need to solve for x. So can you see over here what is there at the top? A 1. Drop it like a heart. Drop it like it's hard. So x is 1. Or x is, remember you can change this 1 into a 5 to the power 0, because 5 to the power 0 is 1. Drop it like it's hard. So x is either 1 or 0. Okay, almost there. We want to find x, solving x. And now this is where we've got exponents, but our exponents is an ugly fraction and we hate fractions. So can you see if you raise it to a further power 3, that you're going to get rid of this whole nonsense over there. Okay. So it's going to be a third. I just want to show you on this side. A third times by 3. 1 times 3 is 3 over 3, which gives you 1. So what did I learn? You take the fraction and you simply flip it over and you multiply with that. All right. Let me just erase here to keep everything nice and tidy. But what I do on the one side, I need to do on the other side. So that falls away and it becomes x to the power 1 is equal to 4 to the power 3, which gives you 64. Easy peasy. Now here, raise it to the further power, flip it around, 3 over 2, because 2 over 3 times 3 over 2 will give you an x. But what you do on the one side, you have to do on the other side. So 4 to the power fraction 3 over 2 gives you a lovely 8. Again over here, I'm going to raise it to a further power 2 over 3. I flip that fraction around, which leaves me just with 1x. And 27 to the power, what I do on the one side, I have to do on the other side. 27 to the power 2 over 3 gives you a lovely 9. Okay, and that I just punched it into my calculator. Same with this last one as an explanation, and then we're going to use it. So can you see that it's flip the fraction around? 7 over 6 times 6 over 7 will give you 1, and 128 to the power of 6 over 7 gives you 64. How do I know that? Punched it into my calculator. Now, this is the last type, and there's luckily 2 of these. All right, so we're almost done. Almost done with all exponents that you need to know for this year. All right, Now, can you see somehow this looks like a trinomial? And this middle is our key that we're going to change it into. So it's just something you have to teach yourself, that you have to remember, that you have to remind yourself when you get to these sums. The quarter is the key. So we want to change a half also into a quarter. So I'm just going to go ahead and do it. And then if I have to take it to the power 2, can you see a power raised to a further power you multiply together, which will give me 1 times 2 is 2 over 4 times 1 is 4, which gives me this half over here. So by doing so, always you take the middle term, the middle fractions exponent, you put it by the first one, and you always raise it to the power 2. Why? Because a trinomial is always something squared, something x, just a number. Okay, and then let's continue. 8x to the power a quarter plus 16 is equal to 0. Now, I don't like what's going on here. I'm going to change, or I'm going to say, let x to the power quarter equal to k. Then I've got k squared minus 8k plus 16 is equal to 0, which is far better than x to the power quarter raised to the power 2 minus 8x. Okay, so now we can see this is a lovely, lovely trinomial. The k splits, they're the same, they're both negative. And what times what gives you 16? If you add or subtract, it gives you 8. And that's a 4 and a 4. So can you see that if you make each bracket 0, that k will be 4. Okay, on both, with both brackets. But now I need to go back and say, what the heck did I say again? What is k? K is x to the power a quarter. Okay, and I'm not done. I need to solve for x. So now this is where those first 3 or 4 that we did comes in handy. So we're going to further raise it to the power of 4, because a quarter flipped around is 4 over 1. But what I do on the one side, I have to do on the other side. So this becomes x to the power of 1. You don't have to write that 1. Is equal to 4 to the power 4, which gives you 256. Okay. Little bit hectic, but not so bad. This is the tippy top of the mountain, the hardest ones you'll get. Let's just do another one to make sure that you've got this. Which one is your key? The 6. So we're going to change that x to the power a third to 1 over 6. And it will always work out that if you square it, that you get back to a third. So let's just check it. X to the power 1 over 6 raised to the power 2 over 1. 1 times 2 is 2 over 6 times 1 is 6. It gives me that third that I started off with. So I didn't change the value of my expression at all. Minus 6x to the power of 6 plus 8 is equal to 0. Oh my word, this looks terrible. Let's say that x to the power 6 is k. Let's make it better for ourselves. Much, much better. Much better. The k splits, they're the same, they're both negative, and 4 times 2 gives you 8, minus 4 minus 2 gives you that negative 6. So k is either 4 or k is 2. Oh, but I didn't start with k. I need to solve for x. What did I say is k? K was x to the power of 6. So x to the power of 6 is 4, or x to the power of 6 is 2. How do I get rid of that again? We want to solve for x. So now, what do I need to raise it to a further power? 6. Because 1 over 6 flipped around is 6 over 1. And what I do on the one side, I must do on the other side. So x is either 4 to the power 6, which is 4096. Yes, we do have such a horrible answer. Or if we do this, and raise it to the power 6. That will fall away. But what you do on the one side, you have to do, come now, you have to do on the other side. It doesn't want to let me write there for some reason. Let's do that. Does a. Okay. Or x is equal to 2 to the power 6 is 64. And there you have it, boys and girls, all you lovely, lovely children. I hope it helped. I hope that you understand all types of exponents. I know this is hard. The kids in my class said, ma'am, exponents is actually quite hard for them. But yeah, if you just understand all these types, you'll be okay. And then after this, at my school, what we're going to do is, we've already started now, is equations and inequalities. So soon hereafter you'll find a video where we deal with that. And I know somebody also asked in the comments of my videos, please do equations, inequalities, solving x and y simultaneous equations, etc. etc. So that's all to come. All right, you must have a fabulous day. Lots of love and look after yourselves. Okay, bye.